Did they know that 17 is my default answer to?
Oh, no. I didn't know that, but good to know.
Whenever I answer 17 is, come on, I said that already.
And then you go to then you have to learn to go there, like on the boats.
Mr. Devon, after this, do you think we can start at the back?
We definitely start at.
I can bounce.
Thank you.
Don't leave. I don't think he knows what bouncing math says. Lock it up. Oh, wait. Only question. No, Bob.
Your laptop went dark. Okay. So we need to take care of, it's okay, of the cotangent to apply FTC1. So what we'll do, we're going to say that by the chain rule, we're going to change that to d du of this quantity. And now, because we made the change, then we can go pi over 4 to u cosecant squared y dy, and then we need to have du d theta, which is negative cosecant squared of theta, like so. Now by FTC1, so we apply FTC1 here, and FTC1 tells you that if you have d du of integral from a fixed value to the variable, then it will be the integrand evaluated at this variable. So therefore we have cosecant squared of u times negative cosecant squared of theta, and now we need to bring back u, so u is cotangent theta, so we'll end up having cosecant squared of cotangent theta times negative cosecant squared. So one more step here, I should have put the negative up front, so the final answer will be negative cosecant squared theta times cosecant squared of cotangent theta, like so. Okay, is that the answer in the back?
Yes.
Wow, we got lucky on the first one.
Hey.
So I work backward now, I work front and back, which is going to just confuse me, but I'll try to handle that. Okay, so 88 is my next question. Find all values satisfy mean value theorem. Okay? F of x equals somebody. Finally, you shut up. I mean, it was so noisy. For a while, I couldn't hear myself thinking.
That was the math.
On the 1 by 11, okay, find find x equals c in 1 to 11 that satisfy mean value theorem. Okay, the solution, what really we want f of c that will be equal to f bar. And f bar is 1 over b minus a, the integral from a to b of f of x dx. Okay, so we need to evaluate f bar. F bar in our case would be the integral from 11 it's 1 over 11 minus 1 integral 1 to 11 of ax plus b dx. So it's 1/10. The antiderivative of ax is ax squared over 2 plus bx evaluated from 1 to 11. So we have 1/10. And at 11 we have 11 squared, which is 121 over 2a, and plus 11b, and at 1 we're simply going to have a over 2 plus b. So let's simplify it a bit. So we have 1 over 10, and let's combine the a terms. So we have 121.5 minus 1/2 times a, and we have 11 minus 1 times b. So at the end we have 1/10, and here we have 120 over 2a plus 10b, and of course this will be 60a, but 60 divided by 10 is 6. So we have 6a plus b. Okay? On the other hand, so this is f bar. On the other hand, f of c is simply ac plus b. So f of c should equal to f bar. It follows that a times c, or c times a, right, plus 1 times b must equal 6 times a plus b. Okay, so you can see that the b equal each other, right? And what happened is ca equals 6a, and therefore c equals 6. So, and that's the answer. So now on to 23. So back to the front we go. And 23, we simply need to evaluate the integral You want me to split? You're welcome. 23, we need to evaluate the integral of sine 10x minus 2 dx. Okay, probably we need to look at the u substitution here. So we let u equal 10x minus 2, and therefore du equals 10 dx, and therefore dx by itself equals du over 10. So 1/10 du. So this is how we substitute dx. We're going to substitute dx with 1/10 du, and now the integral of sine 10x minus 2 dx becomes the integral of sine of u, and instead of dx, we'll have 1/10 du. Okay? So, and of course, we can pull out 1/10, and we have the integral of sine u du, and the antiderivative of the sine is negative cosine. So we have negative 1/10 cosine u plus constant c. We then plug back u as 10x minus 2, and the final answer is going to be negative 1/10 cosine of 10x minus 2 plus c. And I hope this is the answer in the back.
Would you accept 1/10 negative cosine?
I'm sorry?
Never mind.
Say it.
So would you, on the test, would you accept 1/10 negative cosine?
Yeah, it's the same
Same
thing.
thing.
Yeah. So the next one from the top is 86. From the bottom, I'm sorry, I said from the top. We need to find average value. So 86, what's given is f of x equal, is that, I read it correctly, secant squared x? On the interval 0 to pi over 4. Okay, and we want to find f bar, the average value. Okay. So f bar, again, it's the formula is 1 over b minus a integral from a to b of f of x dx. In our case, it will be 1 over pi over 4 minus 0, the integral from 0 to pi over 4 of secant squared x dx. Okay, secant squared is the derivative of the tangent. So, if in here we have 1 divided by pi over 4, you divide by a fraction, you multiply by the reciprocal. So 1 over pi over 4 becomes 4 over pi. Okay? And now the antiderivative of the secant squared is the tangent, and the tangent evaluates from 0 to pi over 4. Well, if you recall, tangent of pi over 4 is 1, and tangent of 0 is 0. So you end up having, I'll do it here, you end up having 4 over pi times 1 minus 0, or simply 4 over pi. Okay. And I think that probably may be still on the test. I'm not sure. It looks awfully familiar to me, and I may have left it over there. Somebody put a group of 83, 84, 86, 88, like consecutive numbers. What is this number? 25 underneath the 26?
Yes. Isn't that the one you said that it slipped into this packet?
Yeah, I think this one slipped into the packet. This one require. Let me think.
26.
26 is not a problem. 25.
Oh, really?
25. I'm trying to think. So if you shut up for a second, I'll see if I can figure this out.
Isn't that like
Integration by part is not included, right? So the only technique that we really have is substitution. And the substitution won't work here. Straight up substitution. What will work here beautifully is trig substitution, but we yet to learn that. So strike number 25. Strike out number 25. Okay? On the other hand, I'll modify 25, so not to waste space. I'm going to give you a similar problem. Okay? I'm going to just make one minute change in 25 to make it workable. You don't mind, right?
No.
Okay, so this is 25 star modified. Okay.
25 on the test.
I'm sorry? You may have 25 star on the test. That's why I'm doing this. I mean, there is reason to what I'm doing.
Life is known for its subtlety.
Yeah, sometimes, so I'll change it to 7x dx over the square root of 16 minus 49 x squared. Okay? So we want to solve this one. So here's the solution. You can see why this is workable.
That's another.
Okay? That's much better. I agree. Because if we do u substitution, we let u equals whatever this ugly thing in the radical. So 16 minus 49x squared, and therefore du equal negative 42 times 2. 49 times 2 is 98x dx. Right? du equals negative. But all we need is 7 98x, and I think 98 is divisible by 7. 14. It's 14. So we're going to write it as it's equals to negative 14 times 7x dx. And as I taught you today, when we do the trigonometric integration, we always after a recognizable differential. So in this case, this is fabulous to have the 7x dx because we have it right here. So we have direct substitution. So we can write that therefore 7x dx, I can write it as du divided by negative 14, or negative du over 14. And now I'm good to go, because now my integral, okay, so instead of having this ugly thing, we have the integral. In the denominator, we'll simply have the square root of u. And in the numerator, we'll have a negative 1 over 14. So negative du divided by 14, of course, we can yank out 1 over 14, and we have the integral of 1 over square root of u du. Now, this is a piece of cake. By now, you should know that if you have u to the negative 1/2, and when you add 1, you have u to the positive 1/2, divided by 1/2, or 2 u to the positive 1/2, or 2 square root of u. So the result would be negative 1 over 14, 2 square root of u, plus, of course, the inevitable c. And now all we need to do is plug back in the u part, and you have the 2 over 14 becomes negative 1 over 7, and square root of u, which is 16 minus 49 x squared plus c. Okay? So I just modified this problem a bit to make it suitable to our course material. You know what? I think I lied to you. Unintentionally, whatever it is, unintentionally. This problem, the original problem, we can solve it without trig substitution.
No.
But we won't sign.
How? You said, yeah, how?
I said no. He said no.
Yeah, with your sign. Looking for the sign.
Okay, go ahead.
Quadratic.
Looking for,
You recognize that on the bottom square root of
so let's do the 25 without the asterisk, without okay. So, the original problem is the integral of, where is it? It's 7 dx, right?
Yeah.
7 dx divided by the square root of 16 minus 49x squared. Okay? Now, we'll do a different use substitution. I didn't let Travis finish all the way to the end, so he didn't get to the crunch line. Right? But up to the punchline. So I'll take the highlight for the punchline. Or I'll let you do that. Okay, I'll stop at this point, and you'll explain it. Okay, but here's what Travis said. I'm paraphrasing on you. Okay, I'm gonna do use substitution, but instead of substituting x squared or 16 minus 9 minus 49x squared, and because Travis told me where to go with it, I'm going to let u equal 7 over 4x. And therefore, du equal 7 over 4 dx. Okay, I need 7 dx, so 7 dx equals 4 du. Now, why the heck I did it? Because Travis told me, look, do this. You have the square root of 16 minus 49x squared, right, in the denominator. Go ahead and factor 16, and you have now 1 minus 49 over 16x squared, like so. And now, completely get the 16 out, because 16 is a factor, and you have 4 square root of 1, and you see 49 and 16 and x squared are all perfect squared, so I'll have 7 over 4x, the whole damn thing is squared. Okay? But really what I have is 4 times the square root of 1 minus u squared.
How's it 704?
I'm sorry?
So that's still not going to be on the test, though, right?
Actually, that may be. After showing you, there is absolutely no reason not to give you in the test. So I still can modify. I still can modify the test. And okay, guys, here's where we are. The integral of 7 dx divided by the square root of 16 minus 49 x squared equals 2. After all of that, okay, equals to the integral 7 dx. We established the fact that it's 4 dy. Right? And the radical, we just looked at it, and it was 4 times the square root of 1 minus u squared. Okay? And the 4 and the 4 cancel each other, so now we have the integral of the u divided by the square root of 1 minus u squared. Travis, back it to you. What is this integral? Or what is the antiderivative here?
sine inverse.
Is the
Sine inverse.
the inverse sign. I know that some people say sine inverse, but it's the inverse sign or the arc sign. So this will be the inverse sign or the arc sign of u plus c. And now bring back u. Remember what was u? U was 7 over 4x, right? So it's equal to the arc sign of 7 over 4x plus c. It's a pretty good problem, isn't it? Okay, so now we go back to the bottom, And after, what we did? We did 86, so we need to do 84. Swimming pool. Wow. Swimming pool. This is also a strong candidate to be in the test. So we have a swimming pool that has a rectangular base, okay? Swimming pool. I'm not going to write everything. So we have base is 12 by 24 feet.
Can I ask you a quick question? Are those average value questions, are those going to be on the test?
I cannot answer this question. It's,
But I mean-
is it between 5.3 and 6.5?
Yes.
There is your answer.
I didn't know that. That's what I was asking.
Yeah.
Oh. What'd you say?
Be nice to each other.
He thinks he's such a comedian.
You never know who's going to be the mother of your children.
She probably knows who the mother of her child's going to be.
The height is 5. I don't know where this comes from, honestly. Those of you who had me before know that this is after hours, so I'm at one point I'm going to turn loose and don't even hear myself talking. Okay, so anybody here is underage, anybody here under 18, I need to give you a warning. That some of the stuff that I'm going to say now will be rated R, so you need to be careful.
You had Craig all summer, and he's been under 18 the entire time.
Man, okay, great. You're immune by now, aren't you? Okay, Ren, I'm sorry. All right, let's go back here. The sides are 5 feet high. The reason I'm yakking like that because I have no clue how to solve this right now. But I'm going to probably it will come to me. And how much work will it take to lower the water level 2 feet to lower the... Oh, the pool is full, and we need to lower it 2 feet by pumping the water over the top. Okay, so the pool is full. So this is the data. So this is what's given. And also what's given is the density of the water. Water density equal something, 62.4 pounds per cubic feet. God almighty, I hate this imperial unit. All right, so what we need to find, work to pump out water to the top to a level of, now let me understand, they want to pump out to reduce it by 2, right, Lois? So it was 5 feet, so to a level of 3 feet. Okay, here we need a picture, we need a sketch to solve it, otherwise we'll be lost. I mean, we may be lost even if we draw a sketch, but at least it will give us a fighting chance here. All right? So I'm looking at the profile of this pool, and I may look at the side that is either 12 feet long or 24. It doesn't matter. Okay? For the purpose of this discussion, let's say this is 12 feet, and I know that the depth, the other dimension that goes into the wall is 24. Okay, the water is full, or the pool is full, and so what I need to do, I need to take a layer of water, like so, and so that this is the thickness of this layer. So I need a coordinate system, so I might as well place my x and y at one corner and go like this. Okay, so the thickness will be the y. And now the steps, remember, we need to find the element of the volume, which is area times the thickness. So what will be the area? The area of this layer of water will be simply 12 by 24, right? Say yes, because that's it. Is. Thank you so much. I agree. I'm very glad that you agree with me. So we have what is it? 24 times 10 and 24 times 2, 240 and 48, 288 square feet. Okay, so the dV, the element of the volume, is area times the thickness. And this is the principle of all of these. We've done it hundreds of times by now. So it will be 288 dy. Okay, now we need to convert it to weight. So to convert it to weight, we need to convert it to, this is now, because we have square feet times dy in feet, we have volume in cubic feet, and we need to convert it into pound. To do so, we're going to multiply it by the 62.4, right? So we're going to say that, and now what we have is dF. Right? And that's the only advantage with using imperial units, because we're dealing with pound per cubic feet. Pound is already a force unit. So dF would be 62.4 or 64.2. What is it? 62.4? Good. I thought they changed it all of a sudden. Times 288 dy. And again, we have pounds per cubic feet, and here the cubic feet, so somebody will multiply it. Or you know what? I don't care what it is. I'll call it C. I'm going to C dy, and this will be in pound, okay? And now you're telling me that C equals to what?
17,971.2.
Should we trust this guy?
No.
C equals 17?
971.2
971.2, and the unit will be what?
pounds.
Pounds. No, pounds per foot, because we have dy. Ah, got you. Okay, we need to have pounds, and you have C times dy. dy is in feet, so it will be pound per foot. It doesn't matter. I don't want to carry this cumbersome number. It's easier for me to work with a symbol C. Okay? Now, what do we do the next? Where do I need to bring the water? Well, I need to raise it from 3 feet to 5 feet, right? So this is 3, and this is 5, and this is y. Remember, we measure y from here, okay? So the difference is 5 minus y. Now, if I was a smarter person, I probably would have set up the origin right at 3 and go 0 to 2. But I'm not that smart, so I'll go 3 to 5. Anyway, this will be y, so the displacement, we have dF, displacement equals 5 minus y. Okay, would have been 2 minus y, but as I said, I'm dumb. So dW, the element of work, will be dF, the force, times the displacement. So we have dF is C dy, times 5 minus y. And now the work itself will be the integral from where to where. We need to go from 3. Remember, we need to take only this water, the water from 3 feet to 5 feet. Again, I would have been better off setting the coordinate at 3 feet, but I did not, so we need to integrate from 3 to 5, all of this. C dy times 5 minus y, or let's write it in a more convenient or conventional form. C is a constant, so integral 3 to 5, 5 minus y dy. And the rest is just calculate the integral multiplied at the end by c. So to calculate the integral, you have 5y minus y squared evaluated from 3 to 5.
I squared that too.
y squared over 2. So what we have is c times 25 minus 25 over 2 minus 15 minus 9 over 2.
Plus 9 over 2.
I'm sorry?
Plus 9 over 2. Minus 15.
Why are you busting my gonads?
Oh, my bad. I didn't see it.
Hey,
I'm sorry.
we can do whole numbers to whole numbers. So 25 minus 15 is 10, and then you have negative 25 plus 9. It gives you what? 16 over 2, which is 8. So 10 minus 8 give you 2, right? So the solution is 2c. Huh? Good? Yeah, wow. Look how it is. Now compare this carrying this number all the way. That's pain and suffering. Mike, you want to say something?
No, I was going to say you need your units, but C includes the units.
The units are pound.
You put the units to C, so just saying 2C is enough.
Wow, people are leaving already?
Later. See ya. Bye. No Bill's test.
What is this? Where this nastiness come from? Be nice to each other. We don't know who's going to be your employer. 36.
So you pull Monday? Study?
Okay, we need to evaluate this. It looks awful, and maybe by the end it will be awful. I don't know.
Can't see it because of the switch.
I'm still running this plate? Wow. I'm going to put parentheses so it will be easier to see what's going on.
Oh man, this is bad.
Actually, it's not that hard because we have a common factor.
Yeah, it's different in each one.
Yeah. Where's my? I need something to drink. So, what say you? What shall we do here?
Substitute. Like what it says.
Probably we need to do twice. You find your bottle? Was it you? No, somebody else left the blue bottle here in the morning. You got it back? I'm sorry?
I got it.
Good, I'm glad. All right, let you equal. Now, the question is, shall we substitute? The whole square root? All right, you said so. Huh?
I did 3 substitutions instead of 2, and that would be why.
You really want me to substitute the whole square root?
Yeah.
All right, if you insist. But I need to do the chain rule here, right?
Yeah.
So du equals, this is to the 1/2, so we have 1/2 times this to the negative 1/2.
Would it be easier?
Just to do what's inside it?
Yeah, let's do what's inside.
Guys, I'm starting, don't stop. And then the derivative of 3y plus 6, so it's 3. And this will be dy. So if we look at it, this way, actually it's pretty cool because if you look at we want to have dy divided by 2 square root of 2 divided by dy divided by 2 square root. So dy divided by 2 square root equals, this is du, so it will be 1/3 du. Hallelujah, that's pretty cool stuff. So now the integral, I'm not going to write the whole damn thing again. It will be is that a 3 in front? 3 sine squared u cosine u, right? And then
That's not really, it's not part of your DU.
Yeah, we kept
You should end up with 2/3 to cancel out the 3, 2, right?
Instead of 1/3 du, keep it as 3 dy over.
Yeah,
Definitely works way better.
yeah. Here we go. Now happy?
Yes.
Let me do my thing here. You're gonna jump on me? So now, what I'll do another substitution. So, okay, at this point I have the integral. It's interesting. That was nice. I like it that you jump on me like this. Cosine u du. And now we see that's wonderful, a thing that we talked about today. So we let v equal sine u, and therefore dv equal cosine u du, and now I equals the integral of v squared dv, or 1/3 v cubed plus c, should be what?
No, just substitute.
Shouldn't that be minus cosine?
Yeah, that's.
dv, if you take the derivative of the sine, it's a cosine. What's wrong with you?
He's thinking anti.
Yeah. So, and now big substitute, 1/3 v cubed. V is sine, so it will be 1/3 sine cube of u. And now u is that ugly thing. Is this the answer in the back?
Yes.
Yes.
You did it.
Okay. Wow. So now we go to 83.
Hold on.
Why? What am I supposed to hold on to?
I'm sorry. Again.
Another. What the heck is the difference between 83 and 84? Huh? It's the same thing.
Different things are happening.
The top is 10 feet below the ground. Come on, guys. This is.
Skip it.
Move the next
Fine
one.
if you skip it. Fine.
It's the same problem.
Yeah, one's a tank and the other's a pool. Though.
Skip it. Bucket, skip it. Go to the next one.
I'm sorry?
Can we do 82 instead of 83?
Can we do 79?
Yeah, that's the same thing, 83.
But it's a tank though.
Yeah, vertical right circle or cylinder tank measure this. I gave you this in class. You have that particular problem in class.
Except local water.
Yeah. Is the oil different?
I think the density, that's the only thing that was.
Yeah, 60 pounds. 60.
That's true.
So, do I need to do 83 or pass? Pass. So, 79.
If you drop the board.
The data. Okay, the initial weight, okay, W sub 0 is 40.6 tons. Okay, the weight of including the weight of the fuel Do you all have the question in front of you guys?
Yes.
Good. Anybody does not have? They're all gone? Okay.
What is one? Is not.
If it is fired vertically and the fuel is consumed at the rate of 2.53 ton per 1,000 feet of ascent. Okay? So, how much work is lifting to an altitude of 10,000 feet? Okay, so rate the change of weight, change of W, the rate is 2.53 ton divided by 1,000 by 1,000 feet. Okay. So this will be a rate of change, ROC of weight, and we need to find work to lift the rocket to 10,000 feet. Okay, so our coordinate system will be at the bottom. And right here we have W equals 40.6. Okay, this is actually the force. And here with Y at 10,000, we have another W, we call it WF, a final. So we're going to look at what happened right here in the middle. And as we go with Y, W in terms of Y, as a function of Y, will be the initial tonnage, 40.6 minus 2.53 divided by 1,000 Y. Okay, so this is the F, and the work will be, I'm saying this is the work, and the displacement will be the Y. So the F of Y is 40.6 minus, I'll use these units, what the heck, W, and the displacement equals the Y, and the work will be the integral from Y1 to Y2 of F of W dy. Okay, that's by definition. So Y1 is, of course, 0, Y2 is 10,000. So it will be the integral from 0 to 10,000 of a 40.6 minus 2.53 over 1,000. I don't think I need to compute from beyond this point, because if we call this A and this is B, it will be the integral of A minus BY, and there is the calculation. So if you want to simplify it, let A equals 40.6, B equals 2.53 over 1,000, okay, and W is the integral from 0 to 10,000 of A minus BY dy. You see, it's easy to work symbolically rather than carry large number. Go ahead.
Did you put W equals 40.6 because it's the initial?
The initial, yeah. When W equals 0, you have 40.6. When W equals 10,000, then you have something else. So that's why it's a slope intercept problem. Go ahead.
Would mom test if we did it as two separate things as you did if you first?
You can, but you need to have negative work. for the fuel that you don't use.
Minus the-
But look what I did. I did the whole work as if the rocket, the whole weight is lifted minus the negative work. It's exactly the same thing. You just take this and separate it into two entities. Anyway, what you end up having is AY minus B over 2Y, and you evaluated it from 0 to 10,000
Y squared.
squared. It says squared.
Yeah.
Okay, so, and that's it. The rest is just apply the right numbers. If you want to take something from this exercise, notice how easy a problem becomes if you assign symbols instead of carrying numbers. I know that some of you like to have the numbers because it gives you some concrete stuff, but believe me, the more steps you need, the more calculus steps are involved, the easier to work with symbols rather than numerical values. All right, shall I do it? I don't need to.
Do it.
Don't.
Do it.
Do it one more time. What is the what is the next one? 26, 21?
You won't.
Okay, 31. That high-low thing drives me absolutely bananas, but you ask me to do it, then you'll get it.
We greatly appreciate it.
Oh yeah, I mean, I'm going to send you the bill for being here, so that's a, come on, who asked me 31? Didn't we just do something exactly like that? You have the sin x dx, guys? After today, you should know how to do it. The integral from pi over 3 to 2 pi of 4 cosine cube x sin x dx. Okay, here we go. You have this lovely thing, the sin x dx. So the solution, you're going to let cosine x, I'm sorry, we're going to let u equal cosine x. Nate, are you done with the previous page?
So yes.
Can I remove the split? Thank you. What are you going to get yourself? Live. Man, this guy needs to check his prostate. Okay, here's this thing. So sin x dx, which we have is negative du. And now I, the integral of cosine. Wait a second. We need to do substitution. Okay, we need to adjust the boundaries. Let's not forget that. I mean, I can do big substitution, but I'd love to adjust the boundaries because I don't want to do big substitution. Okay, so if x equals pi over 3, okay, then cosine of pi over 3 equals, come on, Aaron.
Yeah.
Then u1, this is x1, equals pi over 3, then u1, which equals cosine of x1, equals cosine of pi over 3, or it's 1/2, okay? And when x2 equals 2 pi, then u2 equal cosine of x2, or equal cosine of 2 pi. I'm taking the cynic route, so it's 1. So we have the boundaries from 1/2 to 1, and therefore the integral. Now, instead of integrating, well, we have 4 cosine cubed of x sin x dx. After all the substitution, we have negative 4, because we have the negative sin x dx. Boundaries are 1/2 to 1. Cosine cube is u cube, Sin x dx is du, and we have negative 4 u to the 4th over 4, evaluated from 1/2 to 1. So it will be u to the 4th evaluated from 1/2 to 1. So we are looking at 1 minus 1/2 to the 4th is 1 over 16, right? So we have 15 over 16. Is this the answer in the back?
What happened to the negative?
It's negative. Of course it's negative. Is this the answer in the back?
Yes.
Yeah.
The reason you don't replace U is because you adjusted the boundaries?
Yes.
Huh.
You can either back substitute or adjust boundaries, but not both.
Gotcha.
The answer is yes. $77?
Let's go in.
733. There is an error.
What is?
Error in the answer key.
Who did that? That guy right there.
No, actually, it's a test. It's a test generator stuff. I'm not that smart.
What's the correct answer? Is it 160 over 3?
Well, I'll do it. I think it is 160 over 3. Dave Reinhardt know the answer. He did it. Are we doing 77 now, guys?
Yes.
A spring. Okay, about time to do a spring problem. I'm sorry? A spring has a natural length of 20 inches. So x sub 0 equals 20 inches. Okay? And if we apply 2,000 pound force, we stretch to 20. So x sub 1 is 30 inches with F equal 2,000 pound. Okay, how far beyond its natural length will 500 pound? Okay, so find x if f of x equal 500 pound. The key, whenever you have a point like this, a problem like this, is find the k. Okay, and k measured from x sub 0, from the natural length. So f of x equals kx, where x equals x sub 1 minus x sub 0, something like that. Okay? So, in our case, x equals 30 minus 20, or 10 inches, right? And f of x equal, so f of 10 equals 2,000 pound. So 2,000 pound equals k times 10, and therefore k equals 200 pound per inch. So this is the constant, the coefficient or the constant of the spring, and now we have F equals 500 pound, okay? So 500 pound equals K times X, and therefore, man, you scared the crap out of me. X equals 500 divided by K, or 500 divided by 200, or 2.5, okay? And that's the answer, 2.5 beyond the natural length. Is that the answer in the back? So now to 33, right? The one that is an error. The problem itself, should it be that difficult?
The problem wasn't difficult.
The fact that we have a screwy answer made it a painful experience. Okay, sorry about that. But 33, you have something like this. Okay.
Hold it together.
Find the area of the shaded region. Okay, the solution. We have area between two curves, and we know that the coordinate, we have 0, 0, and we have 4, 16, and we have -3 and -1. So perhaps the question originally, Dave, I think that's what you said, that find the area of the complete region. Okay, but it wasn't shaded, so that's the error. I mean, the question is correct, but the fact that what screwed the question up is this part was not shaded. So in general, we're going to say that the area between curves is always the integral from, let's say, x1 to x2 of one function minus the other. Okay?
Was the other part supposed to be shaded or something? Is that what they are?
That's what David, he calculated with this area shaded.
Okay.
And of course, the integral will be negative, so you need to take the absolute value.
Right.
Somebody asked me about problem 14 and 15, and they went and integrated, but you really need to, if you're asked to calculate the area, there is no such a thing as negative area. So the solution, first let's evaluate f minus g. F minus g, negative x cubed plus x squared plus 16x. This is f, and g is simply 4x, and the result would be negative x cubed plus x squared plus 12x. Okay, the integral from 0 to 4 of f minus g dx now becomes the integral from 0 to 4 of negative x cubed plus x squared plus 12x dx. And at this point, it's just a matter of calculating correctly. And 12x x squared divided by 2 is simply 6x from 0 to 4. David, am I doing okay so far? X squared.
Yeah, we'll stop.
Okay, so evaluate 4 to the 4th is 256. X 4 cubed is 64. And 6 times 16, 5 times 16 is 8. Sorry? 16 times 5 is 80, 16 times 6 is 96.
Nice.
Okay? Now here, 256 divided by 4 is 64. So really what you have, negative 64 plus 96 plus 64 over 3, or the difference here is what? 32. So we have 32 plus 64 over 3. 32 times 3 is 96. 96 and 64 is 160. Did I mention that calculator won't be allowed in these tests?
Is this QF?
I'm trying to think. I'm trying to remember. Are we allowed to use calculator in tests or not?
Yes.
Why? Guys, pay this. What are we doing here? I'm looking at 68. We have a dashed line. Oh, we have two curves. Okay. And we want to rotate. So this is volume of revolution here, right? What are the instructions here? Use the shell method. Volume of okay. So volume of solid of revolution by the shell method. By the shell or cylindrical shell method. Okay, so the function 68 looks like this. I'm going to exaggerate a little bit. Okay, so we have one function on top, go like this. Okay. And this function, the claim is that it's x equals 6 times the cube root of y, and the other is a curve that looks like this, and they meet somewhere, and this function is x equals 6y squared, okay? And we rotate this thing about the line y equals 1. Aha. So this is the axis of rotation. Okay, so this line is y equals 1, and we rotate about this line. So this is the region. Now, because the axis of rotation, the one shell?
Yeah.
What do you want?
Washer?
Yeah, that's
That was washer.
washer with
Yeah.
dy. Exactly, it's perfect.
Okay, I see. What happened when... Okay, I think this line will go all the way down like so. Okay, because when x equals 0, y equals 0. So that's what. So yeah, we can do shell. Here's your shell. Remember, when we do about a horizontal line, the thickness going to be dy. Okay, so we need thickness and radius and height. So the solution. Let's write the solution here. The most important decision is the thickness. So dy. Radius will be what? 1 minus, if this is y, the radius will be 1 minus y. Okay? Does it make sense so far?
Yes.
And the height will be the difference. Okay? So if we call this x1, or this will be x1 and this will be x2, the height will be x2 minus x1. In terms of y, it will be 6y squared minus 6 square root of y. So we can factor the 6 and say this will be 6 times y squared minus y to the 1/3. And pretty much we are done. We have the radius, we have the height, we have the thickness, and therefore the volume will be 2 pi. The integral, we'll talk about the boundaries in a minute, of the 2 pi times the radius, 1 minus y, times the height, 6 times y squared minus y to the 1 cube, dy boundaries. Well, y will go to where is the intersection here? What happens if y equals 1? Well, I believe if y equals 1, we have 6 equals 6. So I don't care really what's the value of x. Well, we know that x equals 6. So this point is 6, 1, and the boundaries will go from 0 to 1. Okay? And that's it. We have the integral of, we have 12 pi times the integral of 0 to 1, and now we need to multiply a two binomials. So we'll FOIL. We have y squared minus y cubed minus y to the 1/3 plus y times 1/3 is y times y to the 1/3 is y to the 4/3 dy. And at this point, all I need to do is take the antiderivative term by terms. So 1/3 y cubed, 1/4 y to the 4th. Here we have y to the 4/3, so negative 3/4 y to the 4/3. And here we have 7/3 because we add 1. So plus 3/7 y to the 7/3. And all of this is evaluated from 0 to 1. So we have a bunch of fraction action here. So we have 1/3 minus 1/4 minus 3/4 plus 3/7, and the rest is 0. So we have, this is 1, okay? So we have 12 pi, and we need to do the common denominator between 1/3 and 7/3, so it would be 21, and we have 7 plus 9, right? And minus 1. I don't like it because I don't like to have negative results. So where did I screw with the sign?
The height, it's supposed to be
It's supposed to
the 6 cubic y minus 6y squared.
But I did not factor out the 6?
No. It's supposed to be y to the 3rd minus y squared. You just have
It's a y to the 3rd?
You have x squared minus x1 when it should be x1 minus x2. And I was going to see if the answer came out the same, but...
This is 6y squared. And if I'm looking at the
Isn't
height,
it top minus bottom when you do functions?
the shell is like this minus that.
I see how like if I slice this.
Oh, well, I did it the other way and I got a positive number. Yeah.
It's, you think that I'm looking at the problem, the way they said solid and dashed. So I didn't even graph it. You think they swapped it? They swapped the function?
No, I'm saying like when I did the problem, I did your x1 minus x2.
Based on this, if I drew it correctly, it's this minus that. Okay? Because the height is this minus this. Go ahead. Go ahead.
What's the reason for doing shell method over washer method for this problem right here?
Just because you're instructed to do so.
We said in the direction.
It says 68.
Okay.
Yeah, it's obviously, it's supposed to be the other way around because
the radius 1 minus 1?
the radius is 1 minus y.
Why?
This is 1, and this is y, and this is the radius. You rotate about y equals 1.
Probably take that so that it's still the same answer.
Yeah, but it means that what they do, they got the function on the sketch incorrect. This is this one, and this one is this one. So it's actually, I'm sorry?
Because 6y squared would take off really quickly between 0 and 1.
Yeah, I think what happened is this one, I need to change a whole lot, but there is also an error here, okay? So if...
Well, on the sketch, it's like, you see where you have like the y.
The sketch is wrong.
Okay.
That's what I'm trying to tell you. So this will be 6y squared, and this will be x2 will be 6 times the cube root of y. And now you need to swap, so the height will be the other way around. So we need to do quite a lot of changes here. Okay, so it will be y cubed minus y to the cube root of y minus y squared, like so. And here we're going to stick negative and not worry about it. Okay, so we continue to put negative in front. Okay, and now we have 12 pi, negative 12 pi, and we have 16 over 21 minus 21, so negative 5 over 21, and therefore we have positive 60 over 21 pi, or 20 over 7 pi. Is this the answer?
Yeah.
Okay, so what happened is the graph in the book, if you see what I see, it moved. I'll show you in a second. Okay, come on.
If you graph that Westergaard, the graph doesn't replace the sketch.
This, you see where it says solid?
We can't see anything.
Not really.
Now you can see. You see where it says solid right there? This is the dashed. You see where it says dashed? This is the solid. That's all there is to it. They swapped the dashed and the solid.
But I solved the one that says solid, I solved it for y. And when you solve it for y, it's x squared over 36, right?
But you don't solve it for y. When you solve it for y, then you look at it differently.
No, I'm just saying I solved it for y so that I can put it in the calculator and get a picture of what the graph looks like. Is that going to be, it's going to look the same?
Yeah, it should look the same.
So this is
Square root of y over square root of 6.
square root of x over. Never mind.
Yeah.
Just figured it out.
Okay, I'm glad.
Next question.
It's well, I need to make a note that I have two problems, 33 and also, which one is this? 68. Okay, so correct. 33 and 68. Okay, now what is the next one? Did we do 36?
30.
No, we left at 33. Yeah.
Yeah. Yeah, I got that.
Well, actually, you know you do the right answer. Like if you got negative 20, once again, over 7 times, the answer you know that you did it. Yeah, so you like you did it.
Area.
But I would just try this.
Area enclosed by y equals sine x and y equals cosecant squared x, and x goes from pi over 3 to pi over 2. Sine of pi over 3, I think, okay, what is on top and what is at the bottom?
Here's I think cosecant, no, the sine squared is on top.
We don't have sine squared, we have just sine x, right?
Yeah, sine x. So we have
Cosecant equals cotangent square theta plus 1.
Okay, cosecant is 1 over the sine, so I can insert 1 over sine x,
Square.
and I'll square the whole damn thing.
Yeah.
Okay. I'm check. We'll see.
Okay, so now I'm looking at this, so let me use the boundaries. Okay, so we're interested to see what happened between, let's do show in terms of pi. Okay, so we want to go from pi divided by 3 to pi divided by 5, by half, by 2, right?
Right.
So the letter is so small, so come on there. Okay, so now let's zoom in. So there is somewhere here. So looks like the magenta is on top of the blue.
Yeah.
Okay?
But I feel like it's just gonna be a little bit to the left.
I'm sorry?
I think it's gonna be like the area that's in between the two boundaries. So I don't think it's actually gonna be actually blocked in by anything.
Like that, and then the y-axis.
Tell you what I'll do. I'll graph it from pi over 3 to pi over 2.
So just did it in the area.
You could do like x equals pi over 2. Is that?
That's what I guess.
Okay?
Cool.
And now let me zoom all. Oh, let me.
Just make an x equals pi over 2 and an x equals pi over 3. And then you would have the lines going straight through it. You can see.
Good idea.
Again, technically, yes. But it looked like this.
There you go. So this is the area. So the blue is on top, and the blue is the cosecant squared. Okay, so solution. Okay, we're going to say that cosecant squared of x is greater or equal sine of x. So the area will be the integral from pi over 3, I don't know why I put the negative, to pi over 2 of the cosecant squared minus the sine. Okay? And so we take the antiderivative. The antiderivative of cosecant squared is negative cotangent, right? Negative cotangent x, and then the antiderivative of negative sine is the cosine. And we need to evaluate it from pi over 3 to pi over 2. Okay? Now, cotangent of, so we have, let's switch it, let's do cosine pi over 2 minus cotangent of pi over 2, both of them are 0, minus cosine of pi over 3 minus cotangent of pi over 3. Okay, so cosine, this is all 0, the two terms. So we have 0 minus 0 minus cosine of pi over 3 is 1/2, and cotangent of pi over 3 is the same as tangent of pi over 6, which is square root of 3. So we end up having square root of 3 minus 1/2. Is this the answer?
No. Square root of 3 over 2.
square root of 3 over 2 minus 1.
It was square root of 3 over 3. So it was square root of
3 minus 1.
Oh,
So it was
cotangent of pi over 3 is like tangent of pi over 6, which is square root of 3 over 3. I'm sorry. You're right. You're right. Okay.
I got lucky. Doesn't have enough.
What is the next one? I'm really tired. Where are we now? 57?
Should we mark off the ones we've done?
Huh?
Should we mark off the ones we've done? Or the rest of them?
Yeah.
No, it's happened like 3 times.
57. Okay, we need the shell method to find the volume. And what time is it? 6:06. So this is like more than an hour and a half that I'm working here.
We just do 50 and call it a night.
57, we have y equals to, square root of 2x, and x equals 2, and about, okay, so find volume by shell about the y-axis. Okay, the solution. So hopefully this graph is not square. I think it looks good. Okay, so we have y equals square root of 2x. Is this one, and the other one is y equal x. X equals 2, I'm sorry. X equals 2, then square root of 4 is 2. So this point turned out to be 2, 2, because this is the line x equals 2. And the region is right there, and we want to rotate it about the y-axis, right? And we want the shell, so here's the shell, right there. And of course, the thickness is dx. So t equals dx, radius r equals, the radius is x, and the height h equals square root of 2x. So this is straightforward problem. V equals 2 pi, the integral of r h t. So x square root of 2x dx. The boundaries on x will be 0 to 2. Right? So, I'm sorry?
Yeah, you said right? I said right.
Yeah, so factor out the square root of 2, so you have 2 square root of 2 pi, integral 0 to 2, x times square root of x. X times x to the 1/2 is x to the 3/2 dx. Apply antiderivative, so 2 square root of 2 times pi, and you add the 1, so 5/2, or 2 over 5, x to the 5/2, evaluate from 0 to 2. So, so you end up having 4 square root of 2 over 5 pi. And we have 2 to the power of, so we have square root of 2 raised to the 5th power. Okay, but we can write this as 4 plus 1. So it will be x squared. This, I can write it as x squared square root of x, evaluated from 0 to 2. So this will be 4 square root of 2. So you see what I did? 5/2, 4/2, which is 2, plus 1/2. So we have 4 square root of 2 over 5 pi, and here we have 4 square root of 2 minus 0. So we end up having 4 times 4, 16 times 2, 32 over 5 pi. Is this the answer in the back?
Yeah, how do you cancel out the square root of 2?
Square root of 2 times square root of 2 is 2. Okay. And we didn't do 37? Find the area of a triangular region, first quadrant, that is bounded by the curve y equal to e to the 2x, followed by y, below by, above by y equal to 2x, below by y equal e to the x, and to the right by, Jesus, what kind of problem is that?
So does that mean it won't be on the test?
The graph then.
Actually, it's a good test problem.
It is? Wink, wink.
That's a good test problem.
That can't be, we asked, what kind of question is that? That can't be.
Do you need to visualize this thing?
I mean, it's like I'm gonna be on the 10th, sure.
So we have two functions. Okay, one is e to the 2x. So I think this is exp parentheses 2x. Let's see if I'm right. The other one is exp to the x. I think I didn't put 2x for the first one. Okay. All right, these are the two, and so let me change colors. Okay, e to the 2x will make it red or something, magenta. Okay, magenta, blue, and the last one is a relation x equal natural log of 6, right?
Yeah.
37. And we'll give it
37.
a red color. Okay, so we need to go a little bit higher to see where the region bounded. So give it a little bit of elevation. So we'll go, you think if I'll go 30, it will be enough?
It's not. Go to 40.
Who was that? That was very nice. And not go to 50. Okay, there it is. So this is the area. So what did they tell us how to? Oh, it's an area. It's not volume. Okay, so we have intersections, and actually you see that once we find intersections, on top you have the magenta. You can see it, but if you go back, on top you have the magenta, which is e to the 2x. At the bottom you have the blue, which is e to the x. I'll sketch it kind of.
Will you remove the split?
I'll sketch it qualitatively.
See, it tells us that the top is e to the 2x, right? Because it says it's 5 above. Okay, 5.
They both intersect at x equals 0. So you have one function, that looks like this, and the other looks like that. Okay? And they all and the intersection is right here. Okay. It doesn't matter what, actually I didn't draw it correctly. The point I'm trying to make is this. The slow curve is y equal to e to the x, and the fast curve is y equal to e to the 2x. And this is simply x equals natural log of 6, which is a straight line. And this is the region. Okay? So if we call this y2 and this y1, it's obvious that the area will be the integral from 0 to natural log of 6 of a y2, the top, minus y1 dx, or the integral from 0 to natural log of 6 of e to the 2x minus e to the x dx. Now the antiderivative itself are easy. The antiderivative of e to the x is 1/2 e to the 2x, and the antiderivative of e to the x is e to the x, and we evaluate from natural log of from 0 to natural log of 6. So we end up having 1/2 e to the 2 natural log of 6, right? And minus e to the natural log of 6, and minus e to the 0 is 1, so you have 1/2. Actually, the 1/2 is inside, not outside. I'll do it on the at the next slide. Okay. So again, for natural log of 6, we have 1/2 e to the 2 natural log of 6 minus e to the natural log of 6. And for 0, we have 1/2 e to the 0 minus e to the 0, like so. Okay? Be careful, because we get used to disregard the 0. Now, e to the natural log of 6 is 6. So what should I do with the 2? Okay? I can square it, right? I can say that this is 1/2 e to the natural log of 6 squared. That will multiply it. And then minus e to the natural log of 6, and this is 1, and here I have 1/2 minus 1, that will be negative 1/2, but with a negative up front it will be plus 1/2. Okay? 1/2 minus 1 and the negative up front. So e to the natural log of x is x, e to the natural log of 6 is 6, so we have 1/2 times 6 minus 6, like so. I don't need the parentheses, plus 1/2. Okay? So we have 3 minus 6 plus 1/2, or negative 3 plus 1/2.
Yeah, don't we have to square
Yeah,
So you square the
that's
6,
Yeah. The first 6. Squared.
that's 36.
Okay, so 1/2 of 36 is 18, thank you. Minus 6, so we have 12 plus 1/2. Right? Or 25 over 2. Is this the answer?
Yep.
So 37. So it's a good problem, actually. It's a good test problem. What is the one from the top that we haven't done? You sure? Whenever I see consecutive number, we have 54 to 57. It's the same group of problems. I feel like 54, 4, 55, 56.
56 is a different one, yeah. The word pop.
56 is the one I told you that is a little bit tricky. Okay, and I forgot how to do it really. It may come to me. I wrote down the solution in my office and I forgot to bring it.
We can just do it like next time. Fine. Fine.
Okay, a water tank we have, we have volume that is formed, V is formed by rotating y equal 3x to the fourth about the x-axis. Is that the x or the y? About the y-axis. Okay? Water drain from the tank through a small hole and blah, blah, blah. We have the Torricelli law. So water drains from the tank. So water drains through a hole following Torricelli law. And the Torricelli law said that dV dt, the rate of change or the rate of loss of the volume, is negative m square root of y. Okay? Find the rate at which the low water level are lowering. So I'll translate. It says at what constant rate does the water level y fall? It's really what we want to know is what is dy dt. So first let's find v. Okay? If you rotate about y equals 3x to the fourth, if you look at it, it's some kind of quadratic function, like so. When y equals 0, x equals 0, and so on. We rotate about the y-axis, so we rotate like so. But we don't know where is the boundary, so we're going to leave it at y. Okay, and whatever method we use, if this is the end of the boundary, let's say right here, some value of x, this will be some value of y. So this is xy. The volume is right here. So I'm probably going to use the I'll use the disk. What the heck, right? We have no problem with me using the disk. Disk is cool. So disk. Here's your disk. So we have dy, right? And r equal x. So disk. T, thickness equals dy. R equals x. So we need to solve for x. If y equals 3x to the fourth, then x to the fourth equal y over 3, and x equals the fourth root of y over 3. Okay? And now you can write it as 1 over the fourth root of 3, and then times the fourth root of y, like so. So, the volume equals the integral of pi r squared. In this case, it will be dy, and evaluate from 0 to y, because this is y equals 0, and this is some value of y. So we have r squared is, r squared will be the square root of 3 and the square root of y, right, when we squared x. Okay, so we can write r squared equals, I don't know what it is. You can write square root of y divided by square root of 3 after you squared everything. So it will be pi, integral from 0 to y, of 1 over square root of 3, square root of y dy. Okay, so we have pi divided by square root of 3, and the antiderivative of a square root of y is 2/3 y to the 3/2. This is the volume. We can beautify it a little bit if we want to. Or we can leave it like that. Okay. On the next page, I'm going to write V equals just a little bit 2 pi 3 squared of 3, right? And y to the 3 halves. Now I'll do dv dt. dv dt is 2 pi divided by 3 squared of 3, and they take the derivative of y to the 3 halves. So it will be 3 half y to the 1 half, right? And then the derivative of y is dy dt. Remember, this is what we are after. I did the chain rule. So wham, bam, bam, beam, and you end up having pi divided by square root of 3, square root of y, dy dt. But dv dt is also equals negative m squared of y, right? So it follows that negative m squared of y equals pi over square root of 3 square root of y dy dt. We are after dy dt after all. Square root of y and square root of y go away, right? So we end up having dy dt equals negative m times square root of 3 divided by pi. There you have it. Is this the answer in the back? Lovely problem, isn't it? Yeah. It's a bad problem. Guys, will you give me a break? Can I stop?
Yes. Well, I'm looking for
This